Hello and welcome to Maths Table. In this lesson of Algebra, section 1.4, we are going to discuss the sum product method, which is used to factorize different kinds of quadratic expressions. Now, before we go into details of sum product method, we need to first recall what we studied in the previous section 1.34 of algebraic identities. There we discussed that if we have an expression of quadratic kind, such as given here, 4x squared plus 12x plus 9, what we used to do is we used to select any of the three algebraic identities that we discussed in that section, such as the first identity was a squared plus 2ab plus b squared. That was applicable for this expression based on the positive sign of the x term. Then what we used to do is we used to determine the values of the two numbers a and b from our given expression by expressing the first and the last terms as perfect squares, because in the original identity that was the case. So based on that, 4x squared and 9 were also perfect squares of 2x and 3, and very easily we could determine the values of a and b for our expression, and hence the final factorized form, which was actually the sum of these two numbers a and b, was 2x plus 3 whole square. So this was pretty simple to factorize the given quadratic expression using algebraic identities. But one important thing to note here is that unless and until the first and the last terms are perfect squares, we cannot apply any of the identities for factorizing the expression. So what if we are given an expression of this kind, x squared minus x minus 6, where the first term is a perfect square, but the last term 6 cannot be expressed as a perfect square of any number. So for this, we cannot apply any of the algebraic identities. We need to use some other kind of method. For this, we need the help of the distributive law, which was discussed in another of our videos, section 1.22. There we discussed one example that if you have two brackets, x plus 2 and x plus 5, and we used to expand them using this distributive law, what we used to do is we just used to select the first term of the first bracket and then multiply with the second bracket, and similarly the second term of the first bracket and multiply with the second bracket again. Then we used to get the final form x squared plus 5x plus 2x plus 10, and in the final step we used to combine the like terms together, 5x plus 2x, and hence we used to get the final expanded expression x squared plus 7x plus 10. So this was how expansion was done. Now if we look closely in the final expanded answer, that the middle term, the coefficient of the midterm, was basically the algebraic sum of these two numbers 5 and 2, which were actually the two numbers of the two brackets. And also the final term, which was the constant term 10, was basically obtained by multiplying these two same numbers 2 and 5. So there is a particular relation between the coefficient of the middle term and the final constant term. So we can clearly see that if we need to go back in the reverse direction to obtain the factorized form of such an expression, such as here the 10 is not a perfect square, just as in the case of 6, we can apply the distributive law in reverse direction exactly to obtain the factorized form of this kind of such an expression. So the general rule which we have observed from this example is that if there are any two numbers a and b in the two brackets that are multiplying together, the final expanded form was such that the coefficient of the midterm was the algebraic sum of these two numbers, and the final term, constant term, was the product of these two same numbers a and b. So based on this logic, we can factorize an expression which is impossible to be factorized using identities. Now let's try to use the distributive law in reverse direction in order to factorize this expression x squared minus x minus 6. Now based on this rule which you have just discussed, we need to find two numbers whose sum is the coefficient of this middle term minus x, which is minus 1, and their product is the last term, which is minus 6. So what we'll do is, we'll start with the last term minus 6. We'll break this minus 6 into two factors such that when these two factors are added together, they give us minus 1. So we'll list all possible combination of two factors of minus 6 and we'll check each combination one by one which fits our criteria. In the first combination, we can see that minus 1 plus 6 gives us plus 5, whereas we need minus 1 here. So this combination is of no use to us. In the second combination, minus 2 times 3 gives us minus 6. But when we add minus 2 and plus 3 together, they give us plus 1, whereas we needed minus 1. So this combination will also be rejected. In the third combination, we get minus 6 plus 1 minus 5. Still inapplicable here. And in the last combination, minus 3 plus 2 gives us minus 1, which is what we require. So this combination actually fits both of our requirements. We can see that minus 3 times 2 gives us minus 6 and minus 3 plus 2 gives us minus 1. So now what we'll do is we'll just split or break this midterm into minus 3x plus 2x based on these two numbers minus 3 and plus 2. Now after that, we'll apply the same grouping method of factorization which we discussed in the previous video 1.3, in which we used to form groups of the first and the second term and the third and the last term. And then what we used to do is we used to select the highest common factors between each of these two groups separately. And after that, we also discussed that when we obtain this form, this can also be written in a much simplified way as x plus 2 and x minus 3. So this was how we can factorize a quadratic expression which cannot be factorized using any of the algebraic identities. Now in the second part, we can see that there is one difference, which is the coefficient of x squared term is other than 1. Here we have 2x squared in contrast to simple x squared in part A. Now what we did in part A, we just broke the last term into two factors. But here, when the coefficient of x squared term is other than 1, we cannot simply break this last term minus 9 into two parts. But what we do is, instead, we first multiply this last term with the coefficient of the x squared term, and when we get the product of these two numbers, which is in this case is minus 18, we then break minus 18 into the combination of two factors, just like we did in the previous part. And then we select that combination just like in the previous part, which when added together gives us the coefficient of the midterm. So checking all these four combinations, the first combination gives us minus 18 plus 1 minus 17, so rejected. Second combination gives us minus 1 plus 18 plus 17, still of no use to us. But in the third combination, minus 3 plus 6 gives us plus 3, the same exact number which we need. So this combination applies in our case. And in the last combination, minus 6 plus 3 gives us minus 3. So this is rejected as well. So now what we'll do is we'll break this plus 3x into minus 3x plus 6x, and then we'll apply the same method of factorization by grouping in this expression, and hence we'll obtain the final simplified factorized form of this expression, x plus 3 times 2x minus 3. So now we have learned that we can use the sum product method to factorize such kind of expressions in which the first and the last terms need not to be perfect squares, and those expressions which cannot be factorized using algebraic identities. But this method can also be used to factorize those expressions which can be factorized using identities. So this is a kind of a universal method which can be applied to factorize any kind of quadratic expressions. Now lastly, we would like to thank you very much for your valuable time in watching this lesson. Please subscribe to our YouTube channel if you like this video, And don't forget to follow us on Instagram to stay updated with our latest videos, or if you want to contact us directly. So thank you very much and have a nice day.